Hello and welcome. My name is Tom. This is my colleague Nicholas. We're both PhD students at the University of Cambridge Computer Laboratory, and we're here today to talk to you about a tool called OPUS that we've been developing as part of a wider project called Fresco, which is a fabric for reproducible computing that aims to make reproducibility and assurance a larger part of computing in day-to-day life. So, first talking about OPUS. OPUS is a research system. It's a system for lineage capture, i.e. it's a system that has the goal of telling you for any given piece of data on your machine, the series of steps that went into producing that piece of data, and various bits of metadata about the process. The system is in active development. It's been worked on for a bit over 2 years now, and we've got to the point where we believe we have a usable base platform, and we're now starting to develop tools on top of this to address various problems. In particular, we've developed some tools to address the new EPSRC data requirements. So today I'm going to talk to you about how OPUS can help you with the EPSRC requirements. I'm also going to talk a bit about what else we can do and what other tools we've created. And finally, I'm going to finish off with some aspects about the system and how you can help us and how you can get to use the tool. So, on the subject of the EPSRC requirements, I'm going to take an example here, the story of a researcher. Our researcher here has been doing some investigation into cats and cat pictures. And as normal for a researcher, he's gone out, acquired a data set, he's made a theorization that cat colour and cat popularity are linked. So he's performed some analysis on the data set he's gathered, and he has then taken these results from this analysis and he's produced a paper. This paper, as you can see, contains an image taken from the data set that he has gathered. It contains a table describing some of the results of his analysis, and it displays a graph showing his hypothesis that as in different segments of the population, the distribution of colours will be different as separated by popularity. You can see here, however, the graphs are all the same, so sadly his hypothesis is negative, his result is negative. However, he has submitted it anyway to the CatPix 2015 conference because negative results are still good science. A few months later, he gets an email, congratulations, he's been accepted into the conference. However, the email also warns him that if he's funded by EPSRC, which he is, there are new requirements about research data that he might have to pay attention to. In particular, he needs to make his data sets available if possible, and he needs to provide various pieces of appropriate metadata about these data sets. So, as you can see here, the artifacts in the researcher's paper are all gathered from the original data set that he collected from the internet, and he needs to make that data set available and provide appropriate metadata about it, in case specifically how the data was generated, when the data was generated, and for what purpose the data was generated. Now, this would normally be a painful and distracting process. He would need to go back through 2 months of work, find out precisely what he'd done at the time, when he had done all of the activities, and try and pull together how this data set was originally generated. However, luckily, our researcher was running OPUS when he originally did his work, and we've provided a tool that we think can help you comply with the EPSRC requirements simply and effectively. So here I'm going to show you my colleague Nicholas here. Demonstrates how the researcher would achieve his goal. He runs our generate EPSRC command on the final output of his research, in this case specifically the PDF document of the paper that he had written. OPUS then goes through and examines the history of the paper and what elements went into its production, and then repeats this process for those elements, spanning backwards eventually to a tree of all of the pieces of data and pieces of computation that came together to produce the final paper. And then the script produces two output artifacts. It produces an archive file containing all of the pieces of code and pieces of data that went into producing the researcher's output, and it packages these together. It also produces a report containing the metadata that EPSRC requests about this. As you can see at the moment, this is a work in progress, but this is a work in progress. You can see here that there is a listing of all the files that went into the archive, and for each file, you can see when the file was generated, how the file was generated, including various pieces of metadata about this process that might be useful for people looking to reproduce your work, and also which of the other artifacts in the archive were used to contributed to the production of that. This is just one way we chose to represent this data. If you had requirements for it in other forms or to interface with other systems, we can produce this data in a different representation. In fact, in particular, we suspect some people might want an XML view of it. So if you take nothing away from this talk, I'd like you to remember that we have a tool that we think can help you comply with EPSRC requirements and make it simpler. This, however, isn't all that OPUS can do. OPUS is a general purpose tool for gathering this lineage data, and we gather a rich and varied selection of data. And we think that we can provide various tools and abilities to support the day-to-day experiences of a data or computational scientist. So here I'm going to take 3 common scenarios that we think will turn up reasonably often in your day-to-day experience, and we've produced tools to address these problems. This isn't everything that we can do with the system, but we think these were 3 particularly common scenarios, and that's why we've chosen to address these specific cases. The first case that I'm going to take a look at is tracking computations. So researchers often work in ad hoc manners where they're interleaving commands for various projects or running commands that are irrelevant to the task at hand. And later in their work, they need to come together and work out what actually contributed to any given product, and it may be difficult to determine what actual elements of their work are relevant to a given output. So you can see here, OPUS allows you to run a getTree script on a given artifact. In this case, Nicholas is running it on the researcher's final paper. And OPUS, again, examines the history of the paper and brings the data together. In this case, it produces a visual graph representation of the structure of the files and computations that came together to produce a given output. This is quite a crude view at the moment. We're looking to make this a more information-rich and a more intelligent display in future. However, for the moment, we think it can still be useful. We think this sort of data flow-orientated view will be useful for people in getting a grasp on their workflows and being able to see ways to improve or alter their workflows to better aid the science that they're doing. The second scenario I'm going to look at is post hoc workflow construction. This is quite linked to the first scenario. It's again based on this problem of researchers working in ad hoc or not entirely pre-planned manners. In this case particularly, when you have run a bunch of commands to bring together an experiment, and after the fact you find yourself needing to work out how you precisely did that experiment, either just for the purpose of recording it, or for the purpose of repeating the experiment with different parameters, or repeating it to ensure that there were no problems or flukes in that particular run. Normally this is a slightly painful task of trying to piece together the elements that went into any given workflow and trying to eliminate anything that's either irrelevant or based on something completely different. OPUS allows you the opportunity to generate a script that will produce any given artifact on your machine. Here, you can see Niklesh has run our GenScript program on the researcher's results file. And OPUS again goes through looking for the history of the file and building a view of in this case, the canonical set of commands that went into generating that output file. As you can see here, the script that's been generated contains a sequence of commands that produce the researcher's results file, where he gathers some images from the internet using a Python script. He compiles his C source code into the CAT scan binary, and then finally executes the binary to process his images and produce his final results file. We think this sort of workflow construction will be useful to people in getting records of what they have done, and also we see this as first steps towards work on automatic parameter exploration or work on harder repeatability or reproducibility of computations. The third example I'm going to take here is debugging contextual changes. Often when you come back to work that you did weeks or months ago, you will find that computations that ran perfectly fine in the past now fail. This is often due to changes exterior to the computation in itself, such as your system being updated by yourself or potentially by system administrators, changing libraries or other things on the system, or data files have been modified. And this all contributes to make what was previously a successful execution of a program suddenly turn into a failing execution. So in our example here, we're going to take the researcher's script that we just generated, and we've deliberately introduced a flaw into this, such that now, when the researcher re-executes their script, it fails. Normally at this point, you would now have to go into an in-depth examination of what was different between your environment now and your environment when you last ran the script, and trying to work out which of the potentially many changes has actually affected this particular program and caused this failure. However, if you're running OPUS, you can merely run our environment difference tool on a given binary, and here you can see it has been run on the CAT scan program and has produced a list of all of the executions of the program that have ever happened. You can then compare any given two of these executions, and here see that it records if the binary itself has been changed, if the resource limits or command line have changed, if the environment has changed, or if the libraries have changed. Here you can see that the libraries linked by the program have been modified, and I would suspect this is probably what has contributed to the failure of the program. So, again to reiterate, these are three scenarios we've demonstrated that we think we can offer a useful capacity to make your life easier. This isn't everything we can do. We have a large variety of data that can provide other tools or other solutions, but these were just three particularly common scenarios that we thought were best to address. So moving on from this, you're expecting me to tell you now, if you want to run OPUS, you need to entirely change the way you work, you'll have to reinstall your system. No, we're deliberately avoiding this trend we've seen in tools to help scientists that requires the scientists to entirely change how they work and the technologies they use. We've deliberately designed our system against this sort of activity, and we've created what we think is a system that's easy to install. We've created a system that requires no changes to how you work. In fact, our goal is that if you can forget OPUS exists until you run one of our query tools, we will be overjoyed. And we've created a system that does not require administrative permissions, either to install or to run, as we know that many scientists don't necessarily have access to administrative permissions on their machines. Such things are kept locked up with system administrators. OPUS has also been designed as an extensible system. So if you're working in a particular domain and you think that there are specific tools that could be produced in your domain that would aid yourself or other researchers working in that area, or if you think having richer or fuller lineage in a given domain would be substantially helpful to you, please come and talk to us. We're willing to extend OPUS to have this domain-specific either richer lineage capture or specific tools produced that work with the data we've captured. I'm going to talk to you, show you here some facts about the system that address some questions we often see. OPUS supports Unix-like operating systems. In particular, we have support for Linux at the moment. Mac OS X would not be a painful change to support, particularly if we have people who are interested in it. OPUS does impose some slowdown on your applications. It depends on how the application behaves. If your application spends most of its time crunching numbers, then OPUS tends to impose a negligible slowdown. If your application spends most of its time reading and writing data, then we apply about a 5% slowdown in the average case and about a 10% slowdown in the worst case. OPUS does have some storage requirements. The data has got to go somewhere. In particular, what we've seen typically with normal runs of the system with people using it, we've seen about 200 to 300 megabytes of data generated a day. We don't think this has been particularly painful to us, although if it is a problem for people, we have some thoughts as to how we can address this data requirement and bring it down. But, for example, a single 1 terabyte hard drive would be able to support a user for 9 years. OPUS is also available for use now. If you're interested, please come and talk to us. We want to work with you to get you to have the best experience you can. In particular, how you can help us help you do better science. So we're looking for early adopters for the system. We want to work closely with the early adopters to ensure that they can make the best use of the system they possibly can, and that we can provide the best system we can. Also, if you have any additions, changes or tweaks to OPUS that you think would particularly sell the system to you, please talk to us. We're willing to work with you to make these changes so that the system is the best that it can be for you. So in conclusion, I talked to you about how we think OPUS can help you comply with the EPSRC open data requirements in an easier or more effective manner. I've described 3 different scenarios where we think OPUS can help you do better science, and we have the possibility to create further tools to address other problems you might have. I talked to you a bit about how the system performs and how we want to work with you to make more users of the system. So to wrap up, thank you for coming. Please email us if you're interested in using the system, or if you have any changes or tweaks or comments that you think would benefit us or benefit yourselves. So thank you very much. Please email us any questions.